Okay, this lesson is 4.2b of degrees and radians, and we're going to actually talk about the applications with angle measure. So in the first part of this lesson, we defined that a radian was equal to the arc length divided by the radius. Well, if you rearrange that formula, then you get a very common formula, which is the definition of arc length, which is S equals R theta. An important part about that, I don't know why it disappeared, is that theta always has to be measured in radians. So that's something you got to be careful about when you're using this formula. So look at our examples. Find the length of the intercepted arc in each circle with the given central angle measure and radius round to the nearest tenth. So 2 pi over 3 is my arc length. And nope, that's not my arc length. That's my angle, given central angle measure. And R is my radius. So my formula is S equals R theta. So when I plug in, R is 2 meters. I would encourage you to keep your units within the problem. It just keeps things straight, especially when we get into area. And our angle is 2 pi over 3, which is in radians. So when you multiply that, you get 4 pi over 3, change it to a decimal, and round that to the nearest tenth. This is going to be 4.2 meters. Okay. For B, I have 135 degrees, and my radius is 0.5 feet. So again, S equals R theta. So this time I plug in, and my radius is still 0.5 feet. But my angle measure is 135 degrees, and I have to have that in radians. So if I want radians, just like we talked about, then I'm going to multiply by, it's not going to be 2 pi over 80, y'all. It's going to be pi over 180. I don't know what I was thinking. So when you multiply that out, you get 3 pi over 8, the decimal form, and rounded to the nearest tenth is going to be 1.2 feet. Okay. Okay, so the next part is talking about linear speed and angular speed, which can be a little challenging for some. And I promise you all, the easiest thing to do with this is to pay attention to your labels. If you will keep those labels in the problem, then you will see that this is just an application of something that you learned hopefully since 8th grade. It's called dimensional analysis. It's called factor label. It's called unit conversion. All the same thing, just different names. Okay, so we have two formulas that you got to know, be aware of. One is linear speed, V, and that's given by V equal to S over T. And then we have angular speed, that's lowercase omega. So omega equals theta over T. And of course, theta would be in radians. Theta is that angle of rotation. Okay, so look at these problems and just watch how, when I do them, I'm keeping the labels in the problem. Okay, so we have this DVD here. Find the angular speed of the DVD in radians per second. So I'm looking for radians per second, if the disk rotates at a rate of 3.5 revolutions per second. So I'm told, well, first of all, I'm looking for angular speed, which is theta over T. Okay. And I know what theta is. Theta is my 3.5 revolutions, and T, my time, is per second. So I've got that written down, 3.5 rev over seconds. Now, the directions ask me to find it in radians per second. So that means I've got to change. I've already got seconds. I just got to change my revolutions into radians. So this is something you don't see written down anywhere, so you do want to remember it. But think about any kind of one revolution is all the way around the circle, and that is in radians 2 pi. So I'm going to multiply by 2 pi is equal to 1 revolution. Okay, when you multiply that out, you of course get 7 pi, and I'm thinking, and I do have my radians per second because my revolutions are going to go away, and pi is in radians. Okay, so when I put that as a decimal, I'm going to carry it out. You got to pay attention to delta math, whatever it says to round it to. So just pay attention. If it said exact, y'all remember this is the exact answer, and that's the rounded answer. But we've talked about that before. Okay, part B says, if the DVD player overheats and the disc begins to rotate at a slower rate of 3 revolutions per minute, find the disc linear speed in meters per minute. So linear speed is V equals S over T. And remember, S is equal to R theta. So when I put that down and I put in the information they gave me, they tell me that I have 3 revolutions per second. Okay? Well, that is my angle, but remember S has to be R theta, where theta is measured in radians. So when I first put it together, what is my radius? Okay, I don't know what S is. I got to go figure out S, which is why I'm going over here. So S is my radius, and my radius, of course, that's showing me the diameter. The radius is going to be half of that. So I'm going to have 60 millimeters, and then I'm going to have 3 revolutions per second. Okay, but I need that revolution to be in radians. So, because that's the only way that makes that S, okay, to get the true arc length. So I'm going to multiply by 1 revolution, 2 pi radians. Okay, so now my radians are gone. I mean, excuse me, not my radians, my revolutions are gone. My directions tell me they want it in meters per minute. So this right here is just putting it in the formula at the beginning. And now I look at my labels and I'm trying to see, what do I need to get to? Well, I have millimeters here. And how many millimeters? I got to get rid of millimeters. How many millimeters are in a meter? And y'all know that there's 1,000. So again, my millimeters are gone and I'm left with just meters on top. And now I need per minute, and I have per second right now. So I'm going to multiply by 60 seconds and 1 minute, and then my seconds are gone. And so the only labels that I have left in my problem are meters over minute. So I'm going to multiply the top and I'm going to multiply the bottom. If you need an exact answer, remember, don't put the pi in there when you use class calc. But if you want the rounded answer, then you get 67.858 meters per minute. Okay, last thing we got to talk about, area of a sector. You had this formula last year, but that formula dealt with degrees. Oops, excuse me, I didn't mean to do that. This formula is dealing with radians. Our central angle theta is in radians, and it says the area equals 1/2 r squared theta. And again, as I keep saying, theta has to be in radians. So look at my 2 problems. Find the area of the sector of a circle with a given central angle of theta and radius of r. So my formula, area equals 1/2 r squared theta. And I'm going to plug in. Again, you want to keep your label in the problem. So my radius is 1.5 feet, and my angle is in radians, and that's 3 pi over 4. So I multiply that out. If I need a rounded answer, then I've got 1.767. Again, pay attention to delta math, whatever he says to round to. Okay, last problem. Again, area equals 1/2 r squared theta, but this time my r is 6 meters. Okay, but my angle is in degrees, so I have to change that by multiplying by pi over 180 because I have to have it in radians. So multiply all of that out. Your exact answer is 5 pi, and your rounded answer is 15.708 square meters. And that's all there is to the applications of our angles. If you have any questions, please don't hesitate to come see us or email us. Thank you so much, and y'all have a great day.